It's all right. I buy it.
Yeah, so funny, guys. Yeah, with the rest of the time, you guys want to touch on a different topic? Chat GPT. I know they've been raising money at a pretty high valuation. I don't even pretend to be a specialist in generative AI. Matt and Carlos, you guys
only
are,
pretend to be a little expert.
There are other things I pretend to be, but that is not one of them. So I don't know if you guys want to touch on that. I thought that was kind of interesting, though. It seems like a pretty high valuation.
Yeah, so the GPT model came out of the OpenAI team, I think 3-4 years ago. I remember when it came out, it's like, this is the end of the world. This thing is going to be spamming everyone, and it's the end of pronunciation as we know it, the English language. So basically, it's a natural language processing model. They've had several iterations of it now. I think they're going to release the 4th version. The 3rd one is out, or 3.5, I think. It's basically a huge transformer model that has like billions of parameters in it. Like, you can't fit this thing generally into memory on a normal computer. You have to distribute it in order to train it. And it's trained on large corpuses of text that can be anything from stuff on the internet or whatever else they've scraped through. I forget exactly. A lot of it's like Wikipedia as well, things like this. And as a result, they get pretty good. You can ask it something and it can give you something back. It can generate a sequence of words that are related to something that you're interested in. And so what they did for ChatGPT is they added like a reinforcement learning component such that it could get better at responding to prompts to give more accurate information.
Matt, can you just outline what the difference is between like a traditional, supervised learning problem and a reinforcement learning problem?
Yeah, so supervised learning problem is you know the output up front. So you have something that you want to train against. That could be ones and zeros, trues or falses. Like, is the market going to go up or down? And then you have a data set and you'll train that data set to best predict whether the market's going up or down. Reinforcement learning will be an expected return. So it's generally some kind of forward path or sequence of events. And you train your model to iterate, to take actions that then lead to better and higher rewards in the future. And it's different because you don't kind of have that decay of rewards that you have in a classical supervised learning problem. And that's the distinction. So supervised learning, you know all the labels and everything up front, and then you're trying to fit that as best you can. Whereas in a reward environment, you have an action and a state, and then you choose actions, and then you have a feedback mechanism.
Yeah, so the way I think about this, it's actually kind of cool because now that I have a toddler, I put reinforcement learning sometimes into the view of like how a toddler learns. So think about seriously, like, it's actually kind of fascinating. So imagine as a for instance, our son Jack, like, we'd like to teach him how to eat with a spoon, right? So if you just put a spoon into a toddler's hand without any context, like, it doesn't know what to do with it. So you kind of need to, give it some guidance. And the way that a toddler learns is it says, all right, I have a state of the world. And the state of the world that I can see right now is that I have food on a plate in front of me and I have a spoon in my hand. And I can take an action, right? So given the state of the world, I can take some action. Meaning I can move my arm any way that I want to, and I can do something with this spoon. I just don't know what to do with it. And the only thing that I will say is that I have a reward. So that reward might be that I've got, I don't know, like PB&J in front of me. Or not PB, like applesauce, because toddlers fucking love applesauce. And so they want the applesauce in their mouth, but right now it's on the plate and they have a spoon in their hand. And without knowing any preconditioned way of mapping it, right, the way that they understand how to do it is by just randomly trying shit. So if you've ever seen a toddler eat and try and use a spoon, it's actually absurd because like they'll poke it, they'll like do stuff. If they do happen to get something on there, they'll flick it across the room or like Jack does this amazing thing where he'll put it on the spoon, and just as he gets it to his mouth, he'll turn it so it goes upside down, and just in between before it gets to his mouth, all the shit just falls straight onto his lap. And so, like, the part of the reinforcement learning process is to say, like, there's no clear-cut answer. Like, no one tells you exactly what to do. The only thing that you can do is you can try a bunch of random shit over and over and over again until you get closer and closer and closer to maximizing your reward. And so over time, the toddler will go from, like, randomly flailing around. So once it gets more experienced, observing the state of the world and, like, taking some action, it will, put the spoon in, and eventually it'll actually get to its mouth in the proper way. But it needs a lot of experience to go back and forth. But basically saying, all right, here's the state of the world. What action did I take? What's the reward? I got 0 reward because it flicked the fucking, like, applesauce on the other side of the room and there's none in my mouth. And the older it gets and the more experience it gets, the better it gets. So with, like, ChatGPT, if you can imagine, they're trying to do well at one thing, which is generating text given some response. So you type in something, and at first ChatGPT is going to, like, tell you, some gobbledygook. It'll be some random assortment of letters, with no coherence at all. And if you train that model for billions and billions and billions of human hours, but distributed across, thousands and thousands of computers, it slowly learns how to do shit. And the more access to data you have, and the more money you can spend to have these computers rolling, like, literally rolling for, like, days and days and days and months and months and months, perpetually learning by doing random shit and trying it out, it'll eventually stumble on the right answer, provided that you have enough time and compute power dedicated to the problem. So that's the really cool thing. And this is one of the things that's somewhat interesting about ChatGPT, is that they've raised like $10 billion from Microsoft. And it's because at the end of the day, if you look at the people that have the resources to really train a model like GPT-3 and soon to be GPT-4, what do you need to do this defensively? Well, you need access to a shitload of data. You also need access to a ton of compute time. And you need a lot of patience and a lot of skill to get these models to converge, because you kind of need to know the ins and outs of how to point them in the right direction. Otherwise, they end up just doing random shit and they never actually learn how to do stuff. So that skill set plus that capital outlay to get access to data and give that access to the compute time that's needed to do this, it's really expensive. It's really time consuming. But when you get it right instead of ChatGPT, it's really powerful.
It's also scalable, right? I mean, it's like, it can be scaled. It's tech, right? So it might be expensive, but then, like, the use cases, anyone with a computer and internet connection.
The use cases are, like, some of the stuff that you can ask it are pretty insane already. Like, you were playing with it quite a bit, Carlos, or something.
Yeah, no, I wrote Christmas letters with ChatGPT.
So give me some context. So, like, what do you say? Be like, "Dear Grandma," and then it writes like, "Thank you for the toy when I was 8." Like, how?
So here's the best thing. You can give it. Let's say, for example, I was writing a Christmas letter to Rob Ridzak and family. I would say, ChatGPT, write a Christmas letter to my friend Rob Ridzak and his wife. Make sure to congratulate him on having twins this year. Thank him for his good friendship in, making sure that I always had a drinking buddy in New York City when I got stuck near Bryant Park, and tell him that I wish the best for his family. So as long as you know how to prompt it, right? Like, if I were to give you a Christmas card that was like, Rob and family, thanks, bullet point, awesome beers, bullet point, congrats on twins, it'd be kind of a shitty Christmas card. But you give that skeleton to ChatGPT and it pops out with a couple paragraphs of well-written prose. It's fantastic. Yeah. So my view on ChatGPT, and I've actually used this for programming stuff as well, it's like, I view it as the same level of intelligence as a first-year grad out of an undergrad program. Right? Like, a first-year grad of an undergrad program, you give them a programming task or a writing task, they're generally going to Google some shit and then put it together with a little bit of context. And then your job as a manager is to understand where it's wrong and give them some guidance. And then maybe in a couple hours, they'll come back with something a little bit better. Mm-hmm. So I think ChatGPT has this amazing thing because it's like having a first-year analyst. You can tell it to do something, it will effectively Google it because it's learned off of public data. It will spit something back to you, and your job is to review it and understand where it's wrong. And then you can actually write back to it, be like, oh yeah, I actually like this, but can you please change this one thing? And it will go back and fix it and give you a better output.
Yeah,
so
and that's one of the cool things is that back and forth with it. Like I asked it, why is there more matter in the universe than antimatter? And it came up with something a bit boring, but accurate. And then I said, okay, now tell me that in the style of the dude from The Big Lebowski. And it and it was like, hey man, so dude, and then at the end it's like, enough said. Like, okay.
Yeah,
I love it. That's hilarious. But so it's incredible. I mean, people have been talking about computer programs replacing jobs, and so far we've seen it. We see McDonald's has the automated kiosks now, and CVS and some of these other places you have these self checkouts. But we're starting to see stuff impacting, like you mentioned, those are like white collar skills, like typically well-educated skills, and we're starting to see them possibly being automated, which is incredible.
I think that there's going to be some really useful applications, not just ChatGPT, but if you think of like what ChatGPT does, right? It takes sequence modeling of words into other words. You can use the exact same technology to do things like, hey, here's a sequence of market data. Predict what's going to happen in the future. Or even better, like imagine if you could say, what if you could shift it to say, well, here's a sequence of market data. Don't predict to me what direction the market's going to go. Tell me what to do. Because like when you're trading, what you find is sometimes you could actually be right with alpha, but you cannot make money. Because they're like, let's say, for example, the market's moving really fast and you're right, but there's no way for you to act on that in a timely way. Or there's a lot of orders that are currently in the order book that have to get filled before you do. So like, let's say you're right, but by the time you get filled, the market's already moved and you're just not making money. What if you could correlate not only just predictions of what the market's going to do, but also say, this is what the market's going to do, and given the state of the market and our prediction of what it's going to do, what do we actually think is the best way to monetize this and make money? So there's some really fascinating things that I think are just getting started right now. I think that the only problem that you have is that language models and computer vision models are actually reasonably static, meaning if I fed a picture of a dog or a hot dog or a pizza to a deep learning model, that's reasonably constant over time. Like dogs are going to look like dogs. So you train the model once and you generally know if something's a dog or not. Or the English language has some drift, but not a lot over time. So if I spend $10 million to train a massive ChatGPT model, well, generally speaking, it's not like in 6 months' time, it's not going to decay and the language won't change as much that I need to retrain it again. Versus in markets, you can have regime shifts. So it's more difficult. So I think finding that balance of, how can I have a model that is adaptive enough to market conditions, but also, learns a lot from the history of markets and has the ability to look over long sequences of data and predict not only a prediction of the market, but also give you an action that might lead to a better monetization, is something that's just really, really powerful.
I'm waiting for you to stop talking in case you end up saying more about what a business
No, I'm done.
Oh, and this is how we do it, by the way.
Yeah, there you go.
That's great, guys. Appreciate the explanation. Fantastic.
Yeah. Well, if you want to know how we do it, you have to buy me dinner first, Matt. So